Hello again. Welcome to this session on FUSA at system level. Now let's briefly touch upon what is meant by system. In this particular context, we are talking about system only electrical and electronic system. So in that context, let's define. Automotive system is network of embedded systems that work together in a vehicle, including applications on processors and manufacturer servers. To just give a more broader perspective, automotive systems are a vital part of the modern life and include many different components such as electronics, mechanical systems, safety systems, drive systems, and all the systems are, to be very precise, they are mechatronic systems. They are mechatronic systems. None of these systems are purely mechanical nor purely electronics. So all these fall into the category of E and E, that means electrical and electronic systems. Now here, if you see this particular picture, you can clearly find out that it is at the level number 4. A fourth part of this entire ISO 26262 is referring to the system level, and we will be briefly touching upon the various subsections mentioned in the system level, like general topics of product development, the technical safety concept, how technical safety concept cascades into the safety of the various components, the system and integration, system and item integration and testing, the safety validation. All these things will be briefly touching upon. Alright, now let's deep dive into that. On the right side, you can see there is something called system level phase model. Under the system level phase model, you can clearly see that there is a technical safety concept. Technical safety concept is derived from functional safety requirement, which is usually an output of at the OEM level. And from the functional safety requirements at the OEM level, the technical functional safety is a concept which is cascaded from functional safety concept, and this technical safety concept is usually given to tier 1 level, and technical safety concept is further cascaded to both hardware level and software level. Now we have to understand, when in the development of functional safety, both hardware department and software departments are there, and usually there is some kind of friction between these departments, and it is the project manager which makes sure that there is a proper cohesive understanding and a proper coordinated planning happens. And at system level, you have to understand that at a system level, functional safety is very important, because this is the system level. It is the system level, the system gets integrated into the vehicle. Now it is always the tier 1, not as a rule, but usually tier 1 delivers a system to the car maker, whether it is a ECU or whether it is a intelligent headlight or whether it is a smart protocol. All these things are usually delivered to the OEM by a tier 1. So this system engineering must have a proper error detection and fault finding mechanism in place. And as you can see in the drawing for the reference phase, this reference phase is always iterative. A system cannot be directly developed in a single shot. It is always a iterative process, and it is only in the last phase of the reference phase model that you can conclusively conclude that a system is ready to be integrated into the vehicle. Now, as already mentioned, technical safety concept is derived from FSR, which is functional safety requirement, and it is made available to the tier 1 supplier. And safety mechanisms must detect, indicate, and nullify. So when you say a safety mechanism, what is the main purpose of safety mechanism? The purpose of safety mechanism is to detect the fault. It should also identify the fault, and there should be a mechanism. That mechanism should deal with that fault so that the fault can be nullified or the fault can be killed, to just put it in a very crude language. Now the safety mechanisms, the technical safety concept must cascade, or it must it applies to production, operation and service. And system architecture comprises of the hardware and the software. Okay, so developing hardware and software is one thing, but integrating hardware and software as per a predetermined architecture is equally important. It is equally important. Okay, so the hardware and software must be properly integrated, and while integrating, proper safety analysis must be done. And when I say safety analysis, processes like fault tree analysis, failure mode evaluation analysis, all these things are required so that you can identify the cause of failures, you can identify which failures are more critical, and also what are the effects of the failures. So systematic error, random, and always remember, when I say hardware error, it can be a random error, and software error is always systematic error. So both the random errors and also systematic errors must be eradicated in a systematic manner. Also, there should be a clear specification for interface where hardware and software interface is happening. Usually there is a layer called AutoSAR, which is clearly a very important part of the interface. And once you take care of the interface, then comes the integration and testing. All the software units which themselves are forming into software, and all the hardware units which themselves form into a bigger hardware, all these things must be integrated as per a predefined strategy. And what is the basis of the strategy? The strategy must be based on specific test cases using methods, and integration must happen at all the three levels. One is hardware level, software level integration, system level integration, and also the vehicle level integration. And evidence at each level that there is a proper that the proper integration is completed is evidence that a proper integration is complete. Evidence that proper integration happened must be put forth and clearly outlined at each level. And overall evidence that the item is safe. And what is meant by item, I will just touch upon in the next slide. Item, okay, just in this slide I will tell you that item is nothing but a system or a collection of components which the end user can feel at the vehicle level. For example, adaptive cruise control or the steering control, all these things comprise of the item level. To show the safety regulations are met at the vehicle level, the development must be methodically integrated and evaluated on multiple levels, from hardware, software integration to the entire level. So clearly understand that once the hardware and software regulation are clearly integrated, then evidence must be shown that the integration has happened properly, and after integration also safety regulations are clearly met. This is of utmost importance. Okay, so hope you understood what exactly is meant by FUSA at the system level.